Now, just like living organisms are made up of lots of tiny cells, everything, whether it's living, non-living, or even a cell itself, is made up of lots of tiny particles, which we call atoms. In fact, they're so tiny that a single cell probably contains more than 100 trillion of them. And in today's video, we're going to explore just what these atoms are and what they're made of. The first thing to know is that each atom is made up of multiple smaller particles, and its basic structure is a central nucleus surrounded by electrons, which orbit around the nucleus in rings that we call shells. Although we've only shown one electron orbiting here, in reality all of the electrons would be moving all the time. The nucleus itself is made up of two different types of particles, protons and neutrons, which are packed together in a tight ball. Now, the most important thing to remember here is the structure of the atom that we've just been through, and also the relative mass and charge of each of the particles. The protons and the neutrons have the same mass, so we say that they both have a relative mass of 1. Electrons, meanwhile, are comparatively tiny and have a mass 2,000 times smaller, which is often written as just very small, or sometimes even 0. Charge is a bit different though. Protons are positive and have a 1 plus charge, and you can remember this as both proton and positive begin with a P. Neutrons have no charge, so we say they're neutral, and this is even easier to remember because the words neutron and neutral both start exactly the same way. Lastly, electrons have a negative charge, which is the same size as the positive charge of the proton, so -1. It can be easy to get all of these mixed up, but the best way to remember it is that we have positive protons and neutral neutrons. And then we know that the electrons are the only one left, so they must be the negative ones. And remember that both of the particles in the nucleus have a relative mass of 1, but the electrons on the outside are much tinier. The size of an atom depends on which element it is, and we'll see what elements are in the next video, but basically they are the different types of atoms. In general, we can say that atoms have a radius of around 0.1 nanometers. Most of an atom is actually empty space because we measure from the nucleus all the way to the outer electron's orbit. It's kind of like the solar system. You have one big thing in the middle and lots of smaller things orbiting it. But between these things is mostly empty space. Now, although it looks pretty big in this picture, the nucleus is actually really tiny. If we compared its width to the width of the atom itself, the nucleus is 10,000 times smaller. Although the electrons are actually even smaller, and if we were to draw them to scale, they'd be too small to see. In this atom that we've drawn, we have 3 protons in the nucleus, and 3 electrons orbiting it. Because the number of protons and electrons is equal, the positive and negative charges balance out, and so overall, the atom is neutral. Atoms can lose or gain electrons though, in which case the charges would no longer balance, and the overall atom would become charged. When this happens, we stop calling it an atom, and instead call it an ion. For example, if we gave our atom an extra electron, we'd still have 3 protons, but 4 electrons, and so the charges would no longer balance, and it would now be a negative ion, because there's more negative electrons than positive protons. We'd call this a 1- negative ion, because it only has 1 extra electron. While if our ion had another extra electron, it would then have 2 extra electrons overall, and be a 2- negative ion. On the other hand, if an atom loses electrons, then there'd be more positive protons than negative electrons, so we'd get a positive ion. And in this case, we have 3 positive protons, but only 2 negative electrons, so our ion would have a 1 plus charge. Now, we take a look at it in detail in another video, but this here is the periodic table, and each box in the table represents a different type of atom, which we call an element. So this box here represents the element oxygen, and this one is the element lithium. We call these boxes nuclear symbols, and they tell us a whole bunch of information about the element. To see exactly what they tell us, let's take a look at the nuclear symbols of oxygen and lithium. The first thing to notice is the elemental symbol, which is the 1 or 2 letter symbol that represents that element. So O represents oxygen, and Li represents lithium. Then in the bottom left corner, we have the atomic number, which tells us how many protons the atoms of that element have. So all oxygen atoms have 8 protons, and all lithium atoms have 3 protons. And this is actually really important, as it's the number of protons in an atom that determines which element that atom is. Lastly, in the top left, we have the mass number, which tells us the total number of neutrons and protons in that atom. So if we wanted to find out how many neutrons oxygen has, we would do the mass number minus the atomic number, which in this case would be 16 minus 8. So it has 8 neutrons. The number of neutrons an atom has isn't always the same as the number of protons though. For example, lithium has a mass number of 7. So to find the number of neutrons lithium has, we would do 7 minus 3, which equals 4. So lithium has 4 neutrons, even though it only has 3 protons. As we said at the beginning of the video, the number of protons and electrons in an atom is always the same. So the atomic number also tells us how many electrons the atom has, which means oxygen would have 8 electrons, and lithium would have 3.